Yeah, hi, I'm Piotr. I represent the website cosmauta.net, and I want to say you about the guys which from simple website start to be company. The main founder of this website are the guys from the different fields of the PhD and PhD student, from the IT, chemical engineering, and also, like you see, the Arabic studying. So it's kind of mixture of people from different fields. We created our website in 2009, and after that, our first success after 1 year in 2010, we reached 1,000 of the articles, and we start to be known in the local of the community. So we decided to do the next step, and our next step was to think, okay, now we have to go to international for international conference, and then we apply abstract to ISC in the Prague. We are accepted, and we are only one of the three people, one of the three of representatives in Poland that gave us a lot of energy to do more stuff, and we did 5 or more articles per day. We successful to contact with the industry from the Poland, Netherlands, the Germany, Estonia, and that for us was a force which instead of the simple website, we create the company in 2012, but we didn't stop there. We move on, and we start to participate in different important events like the Galileo Application Congress, IC again, and of course, SpaceUp. So our next step, what was our next step? Sorry, guys. So our commercial activist is helping foreign company to enter in Poland, advisor and consulting the service, and we did really cool reports. But that is not all. We also did, we still do the stratospheric platform project. We managed to conduct 3 missions to the edge of the space. Since last year, we collaborate with one company to create the game, Race to Mars. Some people saying it's going to be so cool, like Mass of Effect. I don't know, did you hear about it? And now we have 1,500 of the 1,500 of the fans of the Facebook, almost 10,000 of the enter of the website. We did special report about ESA before Poland entered to ESA and after, and we managed to reach the average Polish politic. And after that, our company still move on. We are submit the project to GMS and Galileo. We are reached the finals, but we didn't get accepted. But just recently, we are submit another project for ESA call for the specific for special company. Now we have 5,500 of article, 50,000 of the enter per month. And our readers are from the industry, academic, professional, and passionate. Now what we are going to try to do is that we are going to the IC in the Belgium. We try to do more national space updates in the English, and also broadening regional, okay. Anyway, thank you very much for your presentation. If you would like to move your company to Poland, do not hesitate to contact with us. We can help you with that. And also, my personal ask, probably in your bags, did you see the small paper about to vote for me? I tried to find some funding for my Space Master program. So it would be really cool if you could vote for me. And if you know something more, how can you find some scholarship for my study, I will be glad to hear from you. Yeah, thank you very much.
Thank you. And now we're calling Kate. You're ready? Not? Okay. Yeah, okay.
Not with that, just with the PDFs because I can't get this file.
Yeah, okay, but we'll
Oh, is it on here?
Tu t'en occupes?
D'accord.
Vous voulez faire la connexion? Oui. Oui, mais c'est bon, on peut le PDF et on peut toutes les 15 secondes.
Do someone else first if you want, and I'll do afterwards.
Yeah, okay, so we're first going to have Frédéric Bauer. We still have some configuration to do. Then. Attends, il faut juste par contre qu'on mette la. Tu mets la bonne présentation? Tu mets les five?
Non, mais attends, on va récupérer sur la clé.
Ah mince, donc on fait pas la présentation. Ouais, mais j'ai toutes les présentations ici.
Ah, oui,
Ah, tu veux prendre la clé? Bon.
je veux juste moi le keynote, le point keynote.
Tiens, ok.
Il est où? Il est sur le.
Sorry.
1, 2, 1, 2. Oh, very nice.
Ready?
Yes, I will.
So, hi. Well, I'm Fred. I'm an aerospace student at the Technical University in Delft, and I today want to present you Euravia and how we connect the European aerospace industry to the students. So for that, I will give you a very short presentation about what we are and what we are doing. And the slide should change any moment. Oh, there we are. So who are we? Euravia is the European Association of Aerospace Students. Some of us are interested in airplanes, but I think for today it's more appropriate to speak about space. You can see we were, for example, a group was in Madrid at the telescope, but there will be also some other events about what I will speak later. For example, the Zero G at Adventure in Toulouse. So where are we located? As European Aerospace Society for Students, we are located all over Europe. You can see this very nice PowerPoint magic with the arrows. So where you can see we are present at most European aerospace hubs from Toulouse to Bremen to Munich, but also in all major parts of Europe. We just got a new society in Israel, but now to a bit about our history. Euravia was founded in 1959 from 5 different universities, which means we have 54 years of activities of integrating students. In that time, we experienced the European history integration in aerospace. And as of today, we nearly have 2,000 members in 17 countries and in 36 cities. So what do we do? On a local level, we have engineering teams. For example, in Terrassa, we have rocket teams. We also go to workshops where we learn about how space companies build stuff, for example, satellite dishes. We also organize lectures. For example, in Leuven, we had a lecture about Mars rovers where we try to get the students in aerospace enthusiastic about space project. But we also have barbecues. But the most important part of Euravia is the European integration, so the international level. For that, we have congresses where we meet with 50 persons to discuss our society. We have culture exchanges where we go and meet different societies to get to know the culture, but also the space industry in different countries. We have fly-ins, which is a bit more cultural. But yeah, stuff what students do. We do sleep a lot, but we also go to very nice places, for example, the Pličević Lakes in Croatia last year, or we enjoy the sun in Portugal, which was a very nice event. Yeah, and in the next slide, we will see a bit more what stuff students do. For example, we as engineering society are very proud of the few female members we have, which is very extraordinary. We also enjoy the company of very different nationalities at our events, and we enjoy some drinks from time to time as a student. Okay, yeah, very nice drinks. So, but now a bit more serious. One of our main events is the FOVO, which is an abbreviation for formation workshops, and as engineers we always need fancy abbreviations, which is basically a leadership and teamwork seminar where we try to learn our members how to succeed later in their jobs. So we're going to tell them how our group dynamics, how teamwork works. But more important was, well, for us as engineers, more important are the workshops and symposiums, which is a technical event in any aerospace discipline, but for example, space, which is the most awesome, which is a 1 week of working together on one project. There will be one in Toulouse in 1 week, which I will attend, and I heard we're going to be at the CNES for the ATV launch. But another event is the DIVO, which is a 3-week design workshop competition. It was hosted a couple of years back at ESA, where we had to design a Mars UAV. So there were 30 students working on that for 3 weeks and came up with a design. And the reason for that is to expose talented students to the aerospace industry. So how do we connect these students to the space industry? For us, it's very important to bring these students to the air shows. For example, Le Bourget in a couple of weeks. Or we go to conferences all over Europe to try to expose the students to the new developments in the space industry. That was in Bristol in February. Or, for example, at this conference that was in the IAC in Naples, where we brought 35 students to Naples to experience the new stuff which is going on in space. So these students get excited about space and want to build their career later in the space industry, which I think is very important because not all aerospace engineers some of them want to build crappy airplanes, but I don't know about that. But so what can we offer to aerospace people? We hope that we can engage motivated students with other students from all over Europe, get to know other cultures, other working styles, exchange ideas, and also meet possible employer or employees, depending if you're a company or students. We also, with the lectures, want to promote new space endeavors. And with that, I came to the end of my presentations. For questions, find me later with a coffee. And thank you for your attention. May the force be with you.
Just one moment before you. Okay, now we're calling Gozia Soliga. Please.
Is it working? 1, 2, 1, 2. Yeah, it's working. Yeah, I hope. Okay, so hello, my name is Gosia and I'm a space engineering student from Warsaw. And as I'm dealing with engineering every single day, today I decided to make a presentation a little bit further from it. And I would like to talk to you about inspiration, because basically inspiration is inspiration basically is a thing that motivates us to do something. And I think that I can say that everyone here is a little bit inspired by space, and that's why it's a little bit incredible. And the whole space inspiration started really, really long time ago, when people just look at the sky and see some lights there and try to think what the strange patterns means. And of course, they connect it with religion stuff. Later, people started to look more closely to the stars, which inspired them to look how everything was created, how the planets appeared, and they wanted to learn something about us. Currently, space is not such a kind of inspiration because we're surrounded by it. We've got a GPS system, we've got different materials coming from space technology around. So it's not that far away like it was many, many years ago. But still, space is a big inspiration for space explorers, for scientists and engineers who are still working on missions to know more and more about space and go further and further. Also, it's a big inspiration for science fiction authors and directors of the movies who can take us really, really far away and just try us to learn something more about worlds that can really exist. And basically, for me, these points are the areas where space is the most inspiring place. But that's not all. Space also inspires other, let's say, areas. And one of these areas is fashion. Because fashion generally takes inspiration from every single place. And for example, I think that every star can just wear stars. It's some kind of catchy stuff. And of course, many designers worked on such a things, and that's the thing that you can find. And for example, I love the dress there. So if by any chance anyone will see such a thing in the shop, just let me know. And basically, you can find clothes which have also real pictures. There is a collection which has pictures taken from the Hubble telescope. But unfortunately, the price of these clothes is as big as universe. So, yeah. Also, as we know that women love diamonds. But I think that every woman would also be happy to wear some shiny moon on you or Jupiter. You can find almost everything. I don't know why some pictures do not appear. I'm really sorry for that. So, of course, you can wear space, and you can be a little bit surrounded by space. Because just imagine that you're waking up in the morning, you take your coffee, you go to your shiny living room, and you just walk through your galaxy in your salon. With that, you can catch some good energy and try to explore the world during the normal day. Also, you can walk by stairs, close to your stairs, and it can also give you some kind of motivation. And at the end of the day, You can just lie down on your pillow and dream about more and more space exploration, and maybe you will find some other cool mission to Mars, or just you can be an astronaut or whatever you want. And of course, space can look good, but maybe it can also taste good. And there is one company in Japan who tried to do something with that, and they created the thing that will appear in a minute. Voila! We have lovely colorful chocolates, which represent all the planets. How do they taste? I don't really know, but I would really like to know how they make the taste of Earth or Mars in lollipops. And just like a short summary, it's just like we know that space unites nations, but it also unites all the different areas of our lives, and they just inspire us to see more and more things, because we can find space almost everywhere. And here I put all the references to all these cool pictures that if everyone would like to find them, they exist in the net, because I really think that they are cool, and there is more and more stuff. And thank you very much for attention. The last one.
Thank you. So, Kate now.
Everybody still awake? Good, that's what we like. If you don't know already, I'm Space Kate, and I'm going to tell you a little bit about something when the slides come up. So I don't know if you know about the International Space Apps Challenge, but it was the biggest ever hackathon weekend, taking place in 83 different places, and my team won the London event with this, which is called T-10, which is quite appropriate for a T-5 talk. So it's an app for astronauts and for people on Earth, and it's to solve a problem. If you want to change. Now, here is the problem: clouds. If you're an astronaut, let's just imagine that for a second, and you want to take a photo of London. One, you have to know exactly what time you're going over London. You have to get your camera ready, and you look out the window. Clouds. It's London, okay? So we wanted to do something that was going to save the astronauts time. And we came up with this idea. T-10, and it's a special app that the astronauts will be able to use in space, and they can program in the places that they want to take a photograph of, and it will give them an alarm just before they pass over the place. It will check the weather for them. If it's not cloudy, they get an alarm, and they think it's a good idea. These are the astromonials. This is Ron Garan, who said that he would use it, so we're very pleased about that. But even better, next one. Yes, it's okay, just do it. There we go. There's our man, Chris Hadfield, and yeah, he said that it would be a perfect idea. So we like these people, and we like the app. So let's tell you a bit about the app. Don't worry about the time. There we go. It's a pretty picture. That's what it looks like. And that's what it looks like in real life. It's actually here. As I said, the app will let you, please. When you log in, we have a space version and an Earth version. So we're imagining we're astronauts. So obviously we click space, and we add our location. So we put in London. Do I want to take a picture of London in the daytime or the nighttime, or do I not care? Either. We set that. How much cloud do I want to deal with? Okay, I want a little bit of cloud. You add the location, and it will look up all of the next passes. As I said, it will check the weather for you. And at T-10, see what we did there? T-10 minutes before the space station goes over London, or whichever location, you get a thing. So if you're busy, you say, no, thank you. And if you're ready to take the picture, you can click on the, I'm going to take a picture. And here's the exciting bit. If you're using the app in London, on Earth, obviously, there's not London in space yet, but maybe there will be, then you will get a notification. It will say, hey, get ready to smile because the astronaut's about to take your picture. So the whole point is it's making space real. We've been talking about inspiration, we've been talking about how do we reach people. So this will actually tell you the astronaut is about to take your picture. Now, you're on Earth now. So you click on the button and you say, yep, I'm on Earth. If you click the space one, we'll have a few little jokes, but you have to wait for when we launch the app for that. You say you're on Earth, and it will do the same kind of thing. It will give you an alarm when the space station is flying over your house. Now, you wouldn't believe how many people don't know, A, that the space station exists, B, that there are people on it, and C, that you can look up from your own back garden without a telescope, without binoculars, and if you know where to look, you can watch that thing go over your house, and you can wave. So we have the alert at T-minus 10 minutes again, so you get outside with your coat and your camera, and you can say, let's go, I'm going to wave at the space station. And funnily enough, in the same way that the astronaut thing says, it sends a message back to them. So now the astronauts that are in space, they've been away from home for a long time, maybe they're feeling a bit lonely, and they get a little message that says, hey, there's like 200 people in London and they're waving at me. So it's our way of connecting with them. So there you go, we have a nice little countdown screen, and there you go, 153 people ready to wave. And what we're hoping to do is then, encourage people, the astronauts that are up there, they see all these people in London, they're waving, so maybe they'll send a tweet, maybe they'll take a picture of London, and they'll send it down. So the future of the app, well, in space, we want to do things so that we can connect with the time schedules of the astronauts, so automatically we'll not set alarms if they're busy doing like proper science, because that's obviously very important. And on Earth, we're going to do it so that you can, we'll log the locations on a map, you can share your photographs, maybe we'll have badges for the people who waved the most at a certain mission, maybe we'll try and get like some astronaut patches to them. And I'd like to say thank you for listening. I have some sheets about this, but the most exciting thing for me is that last week it was announced that we won the International Space Apps Challenge. And T-minus 10 is officially the most inspiring app. Thank you.
Okay, now we're calling Guillaume Rambert.
Merci. Yeah. Good afternoon, ladies and gentlemen. My name is Guillaume Rambert from Ries Telecom, and I'm happy to be there today to talk a bit about ecology in space technologies. So, to begin, just a few words about Ries Telecom. It's an information and communication system engineering company which is specialized in critical environment. The idea behind Ries is to develop technologies for dual use, so for Earth and space, and also for civil and governmental use. So its activities, two main axes. One part is corporate services, a second part, research and development of solutions adapted to critical environment. So why ecology? Because Ries Telecom has a proactive position on it. So what it is about ecology? Ecology is about environmental impacts evaluation, so understanding what happens, and remediation, changing a bit the way we do in order to make it better. So there are three main levels of actions. One is before you do the new technologies, you think a bit. During, how it will interact with the environment. And then after, what can you do once the thing is not used anymore? For this, there is a nice quotation from Antoine Lavoisier, a French scientist, is nothing is created, nothing is lost, everything is transformed. So that illustrates well the concept. So talking about space trends and ecology, so it has always been implied into the program and the missions and so on, but not really to the technologies and the solutions which were developed. Why? Because classically there are other problems and space is wide, but as we heard this morning, for example, you all heard about the issue with the space debris. So today it's really a big issue. So to sustain space activities, there is a need to incorporate ecology also in space technology development. So that's why ESA has introduced recently what they called a clean space roadmap. So just a few words, you told there are no regulations. There are a bit of legal context at worldwide level. So United Nations did a few stuff, also at European level, and also at national level, the CNES was also part of the first. So in this clean space approach, there are 4 branches. The first one is tools for eco-design, how to help the engineers, the scientists, as most of the people here maybe, to select the right components and solution when they build a new system. The second point is about the green technology. So once you detected a problem, you search for new materials or new solutions that helps to reduce the impact of the space technologies. The third one, we already talked about it, is space debris mitigation. So for the future mission, trying to reduce a bit the waste. So the major solution was the re-entry, but there are also others. And the last one is about the space debris remediation. So what to do about what is already there, so actively removing the debris. There are some challenges. Among them, I have identified 5. So first one is, if possible, how could we reuse space technology? Because it's already there, so maybe it would be a good idea to reuse them. For this, there are needs for interoperability, for openness, and another one that it was too fast. And second challenge is about the legal framework. So there are some text and so on which don't make the active debris remediation possible. The third one is how make it possible to everybody to access to these opportunities. So about this, we talk about open data strategy for increasing accessibility to this data. The fourth one is the major one, is about the people. So how to change the mentalities. So for this, it's about formation, consciousness raising, in order to share the best practices. And the last one, it's how to make it real, so how to implement it, and for this it's about money. So if possible, avoiding fines, making more it attractive, like a commercial advantage, some grants, all this kind of stuff. So to conclude, what I want to tell today is ecology is a major challenge of humankind, and the answer will come from collaboration between public and industrial partners. And Ries Telecom wants to be part of it, so it's on the way. Thank you very much.
And now we are calling Vincent Reynal. And that will be the last T-5 of SpaceUp Paris. So that's an honor to have this spot.
Well, hi everyone. I am so jealous of old people. Yeah, I wasn't there in the 60s, in the 70s, when space exploration was at the top. I didn't see anybody walking on the moon. Look at that, man walking on the moon. When I look at the moon, I can't help thinking, the man is incredible. Well, it could have ended just like this, and it's gonna come. But it didn't. So, T-4 minutes and 30 seconds in counting, transfer to internal power. Oh, well, I forgot to tell you, I've got a rocket to launch at the same time, so go with me, we're going for a wonderful trip. When I was a child, I was 12, Huygens landed on Titan, and I thought, this is a great day. This could be a revolution. This could disappear. Well, so I was saying that Huygens landed on Titan could be a revolution because we have now the image of the surface of Titan. This is unbelievable, so far from us. I was really amazed by that, and I thought we could find life on it, or at least its conditions. Well, I thought of something like that, and it didn't happen, but I was only 12. The point is that in my school, well, people didn't seem very interested about it. In the media, they don't talk very much about it. And I was wondering, what's going on? People don't dream about space? When I see pictures like that, I want to dream. So what is missing? Men, women, heroes? We don't know who the astronauts are, unless they sing Space Oddity from the ISS. Chris Hadfield was indeed a great example on social media. He made us think about space and look at the Earth. This is really important. In 1962, we chose to go to the moon. At least he chose to go to the moon, not because it is easy, but because it is hard. Yes, we are explorers. When man truly wants something, he's able to do almost everything to achieve it. This is incredible. Within 1 decade, man was on the moon. And 45 years later, we do not know how to do this anymore. Just think about that. In 1969, the compact disc hasn't been invented. Today, it is almost dead. I have an iPhone in my pocket to replace it. I can tweet with it to the whole world. But we can't do something we achieved half a century ago. This is unbelievable. I know this is more complicated than that. But how can young people still believe in space today? T-minus 2 minutes and 30 seconds. The rocket is go for launch. Some say, well, we're not made for space. Some say, we do not need to go further. We live on Earth, this is our planet, we have our own problems. In comparison, I could say that it was not necessary to discover America, that's true. But, well, we do not live worse. Now the Americans are with us, and with America we have NASA. With NASA we go to the moon. That's interesting. We can also say that it is too expensive to go to space. Didn't thought about that. We should give all the money to the US Army. It would be far better for the world, I think. No, we are explorers. We have always been explorers. We need to understand who we are, where we are, and what is beyond. T-minus 1 minute. All tanks at flight pressure. It is time for us to go beyond. This is the right time. It is time for space lovers to make people dream about space again. It is time for mankind to make the next giant leap. With private companies on the road to space, we have now more and more opportunities to achieve great things. People could dream of going to space themselves. T-minus 20 seconds. I am so jealous of all people, but I can't wait to see the future of space exploration. And perhaps we will achieve greater things, and all people will be jealous of me. It's up to us. T-minus 3 seconds, engine ignition, and lift off. It's time. It's time to go. We're going to space, the more challenging trip ever. We're going to dream about space. The world is changing, and we need to share this trip with everyone from all countries. We can't miss this opportunity. Thank you.
My apologies, it was second to last, T-minus 5.
Okay. So, hello everyone. I don't think my presentation will be as inspirational as that one, because it was pretty much amazing. But I just want to tell something about the cool thing that there is going on in Poland. And it's how we are trying to get young people interested in space, in astronomy and everything like this. So consider this scenario. You're 15, 16 years old, you're good at science, you won some competitions, anything like this. But you aren't necessarily interested in space, you are a space lover. So then that's where we come in. We send you a letter because we saw that you won some competition, and we invite you to an astronomy camp. Astronomy camp that takes place in the forest for 2 weeks, in the forest because there is a low light pollution. So there are 50 to 80 participants, there are 20 to 30 lecturers and staff taking care that you are safe. So we are living in tents, it's 2 weeks, it's one forest, there is a lot of learning. That's how a lecture looks like. That's a math lecture right in the middle of the forest. There are some tents in the background. And most of the people are scared of the forest. That yeah, you are not living in a hotel. You are living with all these spiders and bugs that live in the forest. But after a few days, they start to love it. We even play volleyball in the forest. We have a net between two trees. We are singing some songs at the fireplace. I don't know. Yeah, so we are singing some songs. It's not all about science, but it's also about having fun. It's still a summer camp, so it should be fun because they are having some free time. We have telescopes, yeah, because it's supposed to be space, it's astronomy. We have a lot of telescopes. We can make a wonderful astrophotography. And that's the general idea of these camps. So if you want to be involved in this, if you like the first camp, you can go to one 2-week summer camp. They will have 2 seminars in the autumn and the spring, and there is 1 week winter camp. And there is even more fun. There are some games. These kids are playing with non-Newtonian fluid. I think that's how it's called in English. Okay, so how do we know we are successful and the thing that we are doing have some results? Basically, the thing that how do we know it? These people come back. They go to the first camp, and then next year they come back for another, and then year after they are still coming back. After 3 years of being a participant, you become a lecturer or a staff or pretty much anything like this. Because you can only be a participant for 3 years, because then you get old and then you're not a kid anymore. But you are interested in space by then. And the thing that is also great, that is a result of all this, is a community that arose from the Almukantarat space camps. We are all friends. We still hang out. We always hang out if we are in the same town. I'm coming back to these camps because of the people that we are passionate about space. It's like at the SpaceUp, everyone loves space. And another thing is that there is some science, yes, and we see the results of this science. We try to teach them. And so the majority of finalists at the Polish astronomical competition is from our camps. Here is the lecturer is a 2 times silver medalist at the International Olympiad on Astronomy and Astrophysics. And then he's teaching everything he knows about astronomy to kids. We have been going strong for 30 years. The whole thing, this camp, started in the 80s, and they are still there. Every year there are camps for kids, and we are hoping that it will last for another 30 years and maybe for infinite time. Because why can it happen? Because the participants that are coming to camps then become the staff, and it's a circulation. I hope it will never run out. So, summing up, it's the astronomy club based on constantly changing a group of friends. It's not official because we are friends. We are mostly there to have fun, and we try to popularize astronomy amongst the kids in Poland. And if it wasn't for the Uncontrolled Astronomy Club, I'm sure I wouldn't be here right now. Thank you very much.
So now we're going to go into the session rooms. So I'm just going to tell you what are going to be in the next session. Just you may have seen that the grid has a bit changed. We have turned 2 30-minute sessions into 3 20-minute sessions. Okay, so now there are going to be 3 20-minute sessions, and we will all meet here at 2:30 sharp for a special treat. And so in this room, we'll have a talk by our sponsor, Communauté des Villes Ariane, Community of Ariane Cities, about Spend Your Summer in Space. Then in room B, you will have the talk by Michal about Space Interactive Exhibit. You know, you had a question this morning during a T-5. You had to come up with ideas about space exhibits. So that's in room B. And then in room Buzz is at, very far away over there, you have Space Manned Mission. It's written amazing. But there are only 10 seats, so that's it. So now is the time to go to the right room.
Just another word. On the doors of this room, you have posters. If you can write your Twitter username on it, it will be a nice souvenir.
So now perhaps we can start. So good afternoon to everybody. I will introduce myself quite briefly. My name is Jean-Luc Bozet, and I am the General Delegate of CVA, that's to say Community of Ariane Cities. So I will give you a few information on what is CVA. Please, to have more information, just look in your program and you will have the description of what is CVA, what are the missions of CVA, and what are the programs of CVA. And of course, we have a website which will be completely revised during next year, because we have to update it deeply. So what is CVA? It's the gathering of cities and industries dealing with European space transportation. So we have to promote European space transportation, that's to say Ariane launcher, of course, but not only. Now you have also Vega and Soyuz in Kourou. And we have educational program, as it has been set at the closing talk for the preceding T-5. Spend your summer in space with CVA. So we'll hear about personal experience by Ludivine just after me. So just to present CVA, we have a film. And you will be the very first to see it publicly. This film has been developed just to present it at the occasion that we will have next early June. It will correspond, in fact, with our partnership with the ATV4, which will be launched with Ariane 5. And at that occasion, we will present a film with what CVA is doing just for now. So we can perhaps have the film. Il n'y a pas le son. So we have a problem with the sound. You have sound. Ah ben, il y a du son normalement. So as you have seen, we have 20 cities as members, 20 industries linked to the cities, and of course, ESA and CNES as So I was saying that we have two key members, of course, with the space agencies. As I said, European space agencies and CNES, Centre National d'Études Spatiales. So now just I will give the floor to Ludivine. Just she will have the opportunity to explain what she lived during 2007, during the CVA summer session in 2007 in Lamprolzhausen, Harthausen. So please.
Thank you. I will more in general explain what is is it working? Okay. So I will explain generally what are the space summer schools. That it is really interesting to attend them. And so in particular, the three I have experienced, whose first one was with the CVA community. So the three I've attended are the CVA, Albar Summer School, and ISU. Just to know, in the room, who is a CVA alumni? Stand up, please. Ah, the other one left. Who is Albar Summer School alumni? Okay. Ah, yes, there. We have two of them. Who is ISU alumni? Okay. So, not that much. A lot of you can maybe be interested. So first, what do you need to have a space summer school? You need space geeks. You need people like you, willing to be together, to speak about space for all along the day, to dream about space, to maybe not sleep that much, and work a lot on space. Motivated organizers. That's very important. To have a good school, you need good organizers. It's a big deal with logistics. A large panel of experts and lecturers. That's really interesting when you have like international experts coming to explain you their passion and their skills. You learn a lot in only a few weeks. Teamwork. So it's good to sit and to listen to lecturers. It's also good to make some things with the other people around you. So teamwork among the space geeks. And of course, cultural events. Because today's space, it's a really small world. It's an international world. You need to know the other people. You need to know how they work, how they think, how they live somewhere, to really interact in the right way and to be efficient even in professional life. So CVA, you had a beautiful movie just before. So not 42, sorry, it's 20 cities plus 20...
Living association, so some are coming, some are leaving.
Okay.
The right.
Okay, apparently I'm not that wrong on the number of members. Cities plus industries. So that's a really interesting community because they do lots of things. They have several programs from high school to professional trainings, and they are sponsored by state members from Europe, so they are not expensive, just to know. The Space Summer School with CVA. It's for a small number of students, engineering students, and the lectures are toward space engineering for space transportation. I'm not dealing well with the microphone. I hope everybody hear quite well. And you end with teamwork, with small team, 6 people per team. That's the start of a real team, I think. 6 people, you have to deal already with who does what and when you have to deliver to your team. 4 weeks, and it's really intense. In 4 weeks, a small group, you have professors coming from all over Europe, from German university, French engineering school, very interesting. And it's really, it's sponsored by these cities. So first they take the students from these cities, but you can also apply if you are not from these cities, and if there are free rooms, free place, they can admit you in the school. Oh yes, I nearly forgot something important. Any alumni of this summer school have the right to make a trip to Kourou, a cheap trip. I see the eyes opening. Oh, Kourou. So I had the chance to spend 5 days in Kourou, among like what they call a VIP trip. It was in 2007. We met the managers of the first ATV. It was before the launch of ATV, and we could speak with them, with the engineers of Kourou. So it's also a great experience. So this trip is organized by CVA. It's 5 days around December, and only for alumni of the year or before, from before, those who couldn't make it before. And really cheap also. Anything to add? Vous voulez ajouter quelque chose ou après je passe aux autres écoles? Second summer school, Alba. Alba is organized by ESA in Austria. Also organized with FFG, the Austrian Space Agency. Here you have bigger group, 60 students. I mean students of the summer school, but they are professionals in this summer school. You have engineers already working in the industry, and also scientists working in observatory in Europe. So for this summer school, you need to be in the state member of ESA from one of these countries, and you get, as soon as you are admitted, you get a scholarship from your country to attend it. So then every country, they don't give the same amount of scholarship, but still you should have nothing more to pay or nearly. And they select the people, and it's really interesting. If you are from the technical side of space, you learn a lot about sciences. If you are a scientist, you discover what are these technical geeks. It's really good. It's only 10, 12 days, really intense also. At the end, the teamwork is about like comment on dit appel d'offres? It's to propose a mission, a space mission, and only in 10 days. We are inside the big team of 10 engineers and 10 scientists, and at the end it's like if you are in real world. It's really short, intense, but you end with a real project. Then ISU. ISU is a lot bigger than the two previous schools. It's for the whole world, for all disciplinaries. You meet experts from anywhere on space. You have space scientists, space engineers, but also space lawyers, space managers. So really any specialties of space. But also it's for 2 months, and you really you know people. I think I met people I wouldn't have a chance to meet them because they are in the other side of the world. So now I know really the space geeks that are very far, and that's great. So like the others, you have a team project, but here it's not 6 or 20. It's with like 50 people from different cultures. So that's a great experience. Okay, so the idea is today you have a lots of things to do in space field, a lots of way to get into the space community. You are here today with the SpaceUps. It's already a big step. For those of you who would like to know more, I think space summer schools are great. You will learn a lot about the other fields. You will know many people from other companies, agencies, countries. I really We would like to motivate you to check anything you can do, and also to be active. Like today, we have the SpaceUp thanks to the organizers. So there are active people, but if there is no actions, there is nothing. So just go on, check on internet what you can do. And thank you for having a living SpaceUp. Thank you to the organizers.
So as I am here, just I can give you some practical information for this year. As you have heard, it's open to young engineers, young people like you. I am speaking about the summer school. So we have still places. And if you don't come from a European Ariane city, the fee is a little bit different. So you will pay. I can give the exact figure: 1,000 euro for attending the next summer school, which takes place in Heilbronn-Lampolshausen. The theme will be energy in space transportation, and the project will have the goal just to build a hybrid rocket with the help of DLR Lampolshausen. And as it has been also said, as a reward into bracket, we offer to each alumnus to go once to visit to go to French Guiana to visit the European spaceport, and financial participation is around 700 euro, depending on the cost of the flight ticket at that time. And I can tell you that going to Kourou for 700 euro, it's quite cheap, and as you heard, you will stay there at least 5 days. So I am available at the end of this meeting as other alumnus of CVA. Thank you.
So he gives a price for CVA, but also for the student from the cities, Ariane cities, it's even cheaper. I don't know if you tell it. It's 150 euros for 4 weeks with accommodation, food, lectures. So it's really nothing. For the other schools, so for Albar, everything is paid normally by your country, by your European country. And for ISU, it's expensive, but you have a different way to get a scholarship according to the country you come from. And if you are from a country that cannot get any scholarship, ISU provides some scholarship, a few of them. So, if you have any question.
Okay, thank you. We have some time for a few questions.
I just want to be specific about Albach. Albach is not just for the ESA member, also for the country which cooperate with the ESA. And it's not like, so far what I know, that the national agency of the ESA country have to pay for your fee during the Albach. So it's probably just like if they want, they are not obligated.
Yeah, it's quite unfair. It depends on the country you come from. They will provide a certain amount of scholarship. So, like the day I went there from France, I got 1,000 euro to give the figure. And with this, I had to pay the trip and accommodation there and food, and it was perfect. Food, I don't remember if you have to pay yourself or no, maybe it's inside the scholarship, the fees. And for ISU, it's like 17,000 euros for 2 months, and you have also to pay your own trip. But as I told you, there are different scholarship to get, and so there is a little bit research to do.
Just to remind you that we are in the middle well, we are changing the sessions right now. This one is a double session, so we will continue getting questions and talking about it. But if you had a session that you wanted to see, you can check the other ones.
Okay. Can I ask more questions? Can I ask questions? Yeah, I have a question. What if you're not a university student and not an engineer, and there are still places open? Are you able to join?
Yes.
And what's young?
Yes. You were asking specifically for CVA, so that I let him. Okay.
For CVA, we are fully open. Historically speaking, it's open to engineering student and young professional, engineer professional. But it could be a good opportunity just to open it to motivated people, as you are all here. And so we can discuss, and it could be effectively a first step. But be aware that, of course, it's a technical input. Of course, we address electronical engineer, mechanical engineer, so we have not a very focused topics on techniques. But you have to have some background, but you will be with other participants, and I'm sure they will help if you or somebody else not having the engineering background as problem, just to be available to help you and give information. And you have, it's in universities, it's organized by, I made it in 2003 in University of Liège. This time it's at Heilbronn University. So you have a staff for having, which is available for giving you some information and answering questions if you have. So we are definitely not blocked on opening it to. There is also effectively, just to make people aware that Europe, it's several language. So there is some training in French, in German, in Italian, because 3 years ago we were in La Sapienza in Rome, and of course some course in English. The courses are delivered in English. So that's for CVA.
For the other CVA summer school, in AppBar, the selection is done by the Space Agency. The people I know were either engineers, scientists, or students. But maybe you can apply, because nothing. And for ISU, I know specifically a French who was looking for a job, who got a full scholarship almost there.
So do we have another question?
Je sais pas, non, elle vient d'arriver.
So we have some free time now. So we have basically 15 minutes left until the next session. So if anybody wants to talk about summer school, we are good to go. And if someone wants to launch a new subject for 15-minute discussions, we are open. Remco? You have a subject?
Okay. Filling 15 minutes should not be too difficult. Pretty rare, actually, that you get some extra time. what I want to talk about is a few things, and I'm looking at you, Claudia, to help me, and there's a few others. We were talking over dinner last night that we would really like to involve an even bigger audience in this whole space social media thing. And with the upcoming IAC this September in China, we have the opportunity to link into a whole community of space tweeps that is out there that we're not currently reaching through social media like Twitter and Facebook, because those are banned in China. So without having given this a lot of thought, we're actually looking for maybe a little discussion on ideas how to involve 1 million people in China in this great global community that we're building. I mean, we are connected right now, right here, through the video stream, through Twitter, through Facebook, to most countries in the world, but probably not to China. At least I haven't seen any tweets or any comments coming from there. So with the IAC, we're looking at ways to involve the public. And in order to talk about it, I need to introduce myself with yet another hat. That is, I'm the Executive Director for World Space Week. And as such, I'm a member of the International Astronautical Federation. And together with the Space Society's committee of IAF, we are going to organize an event at IAC. So anyone of you that is going to be in Beijing in September, please have a look at the program, because the IAF and World Space Week are going to organize a forum on the future of space communication and outreach. What we really wanted to do is what we did last year in Naples, is do a tweet up. But obviously, that's the reason why we're bringing it up. A tweet up in China, with Twitter being more or less blocked by the Great Firewall, might be a little bit difficult. So we're thinking of ideas on how to involve the Chinese space community, young people in China, in our community, and to connect and make it a truly global, uniting thing.
There are some Chinese tweets following Space Unite, actually.
Well, there you go, that's a start. On Twitter?
On Twitter.
Okay. Now one of the ideas that I had is we will organize this event. We will not be able to organize a tweet up in China, but I'm actually calling upon you here to follow the live stream of the event that we're going to do in China. It's an evening event in China. That means it's the middle of the day in Europe, early morning in America, in North America. But I'm actually counting on you guys to maybe hook into the live stream and make it a tweet up from outside the Great Firewall. Because I'm going to be in China, I'm going to be unable to tweet, but all you guys that are not going to be in Beijing are able to tweet. So that was one of the ideas that I had, and that's why I took the opportunity to talk to you guys to introduce this. This is brand new. It has not really been scheduled yet, but it will happen. So if you can, in September, just make sure you follow me. I'll announce the times and the schedules. But trying to make it a tweet up, using this global community and trying to involve the Chinese that way. So if you have any additional ideas, please let me know.
Yeah, I have a bit of an idea. I had dinner with like 5 students from China last Thursday, and they're all very much connected with their people at home. So I don't know exactly how they do it, but I believe there's different social media. So I guess you should approach, because there are lots of Chinese students all over the place, and I guess they would know. So perhaps that is a way to get the ball rolling in such a direction.
Yeah, that's actually a very good idea, because there are social networks in China that are as popular as Twitter. It's just very difficult for us, not speaking Chinese. At least I'm assuming most of you don't speak Chinese that well.
Actually, I realized it's pretty easy to use, because I think Weibo used to be a complete copy of Twitter at some point. So even the links were the same.
It is, but all the tweets write in Chinese.
Yeah,
No, but I mean. Yeah, but seriously, that is something. So I'm looking at maybe some social media expertise in the room to help me connect to the Chinese.
Yeah, and point is, I mean, connecting to Chinese, it's, as you said, it's tricky from the point of view of language and stuff like this. But connecting from China to the rest of the world, that's pretty easy, because you just need one person who has a working VPN network and then you can approach anyone outside of the China. So if there is a tweet-up event in China, it's very easy to make it as a bridge between those two separate words, actually.
Right. Well, I could definitely use some advice there, because I don't know exactly how that all works, technology. And what I want to do is I want to involve the Chinese audience as much as the international audience, and as you say, build a bridge that way. So any ideas, yeah, please let me know.
Okay, thank you. This is the end of this session. We will go to the next session with Richard Edman, who will talk about Mars mission.
Okay, do you hear me? No? It's okay? A few words about me. I'm a retired space propulsion engineer working my career mainly on Ariane launchers. And I'm also the founder of the French chapter of the Mars Society. And today I would like to make a few comments about the main challenges that appear to be eventual showstopper for the Mars mission. What I call here showstopper are topics which are perceived as unmanageable in the frame of a realistic program. There is a lot of them, and these topics are raised mainly by the opponents to the program to show that we cannot have this kind of endeavor. But more often, we see that those problems are largely overstated, and in fact, the possible solution are poorly surveyed. The first difficulty, the first challenge is weightlessness. We have to recognize that this is a pet subject of space medical research. We have studied the weightlessness effects on man since half a century, and we are going on the ISS. It could continue and continue and continue. But what is curious is that we don't even look at the actual problem, which is what is the effect of a partial gravity. Because space flight is not aimed just to fly in the interplanetary or in orbit, but to go to a celestial body. So the important thing is not weightlessness. The important thing is what is the effect of reduced gravity. Another remark is that if really we cannot manage weightlessness for the duration of travel to Mars, why not use artificial gravity, which can be induced by centrifugal systems? But in fact, the duration of 6 months has been yet experienced many times on the ISS, and we see no reason to consider weightlessness as a showstopper. The second item, more serious indeed, is the problem of ionizing radiation. Now we have some facts. Thanks to Curiosity measurement beginning of this year, we found that the level of radiation of Mars is in fact equivalent to the radiation in the ISS, which means that Mars, which from some time was considered as very dangerous from this point of view, is equivalent to the ISS. Yes, the interplanetary transfer is more dangerous, as the level measured also by Curiosity is about 2 times the level on the ISS. So it's really a more serious problem, and that's why we try to reduce the transit time, or to find a way to shield the spaceship from this cosmic radiation. But all in all, we find that the total dose that we can compute during this mission is coherent with the ISS international regulations, which have been set in 1995 at the beginning of the operation of the station. But it is fair to recognize that we are still lacking some medical data about the effects of some kind of radiation on the living matter, mainly the effects of the heavy ions, like iron ions, for instance, And here also, this is a curious fact because it's quite easy to acquire those data, and for half a century we did nothing. Now, since a few years, NASA has established a specialized laboratory with a particle accelerator to get data about the effect of those special particles. My point of view about this topic is that the risk of getting late cancer in the life of the astronaut has to be compared with other technical risks of the mission. And when you do that, you see that the technical risks, like engine malfunction, for instance, are much more important than this late cancer risk. And you have also to compare the risk taken by a few people, the astronauts, compared to the progress in medicines and the treatment of cancer, which will result on research to protect the astronauts. And of course, the balance is very favorable to the mission. A more difficult issue to discuss is psychological issues, because, as you know, this is not hard science. It's very difficult to have a forecast about the behavior of people in very special situations, and we have, since the beginning of space flight, a large number of examples where strange behaviors have occurred in those kind of circumstances. So this is really a field where more efforts are to be made to have more data and to more understanding of the behavior of people in such hard conditions. The main fact is, the main stressing factor is not the duration in itself, but the duration combined with the absolute isolation of people. That is the fact that they cannot return quickly, as this is the case on the ISS, of course. There is a lot of induced risk on the level of personal health or on the level of the operation of the crew as a whole. We have to make use of course, space flight experience, past programs, the experience from extreme environmental Earth, like in the Antarctic, also in submarines, and specific simulation are also useful, like Mars for 500 was last year. And the reason for optimism is to consider that extraordinary individual accomplishments made on Earth have demonstrated that the humans are able to endure and adapt to extraordinary conditions. A more technical issue, which has been from the beginning under-evaluated, is the problem to descend on Mars. Up to now, we are able to descend with a mass of about 1 ton, like this was the case of Curiosity. But with the present technology, we are not able to descend with about 30-ton spacecraft, which is what will be needed for a manned mission. So clearly, we need progress in technology, either scaling up the current technology, like heat shield or parachutes, but it's quite difficult, or finding new technology, like, for instance, balloons or things like that. Due to this fact, some designer of the Martian mission architecture in NASA took very heavy margins saying that we don't know very well the problem, so we take very high margins, and the result is a DRA-5 mission, which is, of course, completely unfeasible, and which can be considered, in fact, and that's my feeling as a political project killer. They put forward those difficulties to show that the mission is impossible. But look, for instance, at the TPS, the thermal protection system, they took a mass of 40 tons, which is totally ridiculous. And for the propellant to descend, the final descent on Mars, they took a margin of 15%, which is also killing the project. In fact, there exists other means to reduce the problem. Is, for instance, to reduce the crew size. We consider 6 because it's optimal for the spectrum of competencies, but we can do a mission with 4 or even 3 if necessary. We can also split the payload in 2, having 2 smaller spacecraft. Safety is also a very special programmatic attribute because it is very touchy. You don't see in the NASA documentation figures about what should be the probability of loss of crew of that kind of mission. It's difficult to assess, of course, and it's impossible to measure because before accomplishment of actual mission, you have no measure of the safety. The Mars mission, of course, is particularly stressing, but there is also a certain number of means to build safety. The first one being the fact that you have men on board. And this is very important, provided designers are able to take that into account. Space industry designers are used to build automatic spacecraft, which are, of course, not repairable, but should be only reliable. In this case of a manned Mars mission, the equipment should be repairable, maintainable by people. The other main factors to obtain safety are, of course, redundancy, as we know the possibility to send spare, building mission robustness, which means that each phase in the mission should have a backup. If this phase failed, you should be able to diverge on a backup phase. You must seek for simplicity. Here you have 2 illustrations. In the bottom, this is a Mars Direct proposed by the Mars Society, which is very simple, as the name said. And above, you have an example of what is a nightmare with a special space station around the moon, around Mars, and so on, and numerous spacecraft. This is not the good way to ensure safety. And the last one is abort to Mars. It is quite interesting to remember that at the beginning of the space era, Mars was considered as a dangerous place. And the first mission architecture envisioned a very, very short stay on Mars because it was not very well known. In fact, this is quite the contrary. In case of a problem, the crew should have the possibility to find a safe haven in the habitat on Mars. Last point, the cost. This is often understated. I mean that when you look at architecture project, you have a lot of technical details, but very few indication about the cost, how the costs are balanced with budgetary capabilities, and what are the means to reduce or to master cost. In fact, the main criterion for the success of a project is not its probability of success, it's at first hand its probability to be accepted and launched. There is a certain number of means to adapt costs by the crew size, by the science equipment, the planetary mobility means, and of course, more importantly, the technology readiness. If you choose technology which are in hand, of course, you reduce the cost. To finish with, we can see that those concerns are real, no doubt about that, but in each case, we can find ways to solution, provided the political will and the skills we have today on hand, especially with the ISS experience, the project development is possible. More ethical consideration, we have the unique capability to escape the planetary trap, which is so often discussed. Should we miss this chance? And I put here a picture of an ape, an orangutan, who cut by himself his arm to escape a trap. Are we able to do the same thing?
Thank you.
I don't know if we have time for a few questions.
We have 5 minutes.
Okay.
Lots of really interesting figures and stuff in the presentation. Will it be available online? The presentation, the slides?
Available on what?
Will they be available somewhere?
Oh, yeah, yes, sure. Well, you have the file, so no problem.
Yeah, okay. If you agree.
I agree. No problem.
We will try to put most of the presentation on the website, unless the authors don't agree.
And in fact, if you are interested in more details, I have a more developed presentation.
Okay.
And come to see me after, and we can discuss that.
Will do.
Okay.
Maybe if you talk about the board to Mars scenario, shouldn't we have some shelters or somewhere already put on Mars in case that somebody has to go down, that they can sit somewhere and wait safely until rescue can
Okay, this is a very interesting point I had no time to discuss, but since the Mars Direct proposal, all the projects designed by NASA are split missions, which means that you build the mission on two launch opportunities. On the first launch opportunity, you put on Mars and around Mars the maximum of unmanned infrastructure you can do. And 26 months after, only, you launch the crew with its habitat to land on Mars, only if you are sure that there is a safe habitat on Mars yet ready to be occupied. And in the same time, you launch the infrastructure of the second mission, which means that in the case the infrastructure of the first mission fail, they can use the infrastructure of the following mission as a redundancy, which means that this concept of architecture gives a free redundancy, which is very smart. Other question, perhaps?
I have another one, if that is okay. You said the transitive radiation was about twice the ISS. Does that include the possibility of like a direct hit of solar flares or other coronal mass ejections?
Solar flares, or solar particle events, as we call them, is a very specific problem. But in fact, it is not the issue, because the particles in the solar flare are not so energetic as are the cosmic rays. And the solution in the case of a solar flare is to get protection, shielding in a small part of the spacecraft where walls of polyethylene or tanks of water will be put to protect the astronaut from the protons of the solar flare. And a thickness of about a foot of water, for instance, or polyethylene is sufficient to protect the astronaut. The real problem is galactic cosmic ray, because they are very energetic and you cannot protect from them. Or you can reduce, for instance, if all your spacecraft was protected by a foot of water, you can reduce the dose by 2, which would be okay, but the mass induced is very big. So the good way is to speed up as as much as you can.
Well, I may have another question. So
Yes.
you were talking about well, the technical challenges and also the challenges to have the mission being accepted.
Mhm.
So that's in the usual way we are doing a space mission currently. But there's a recent trend in having private missions. So what is your feeling about it?
Okay. About the role of private initiative to the accomplishment of such a mission, from my point of view, such an important mission will always need the support of a government. But the private initiative are helping a lot because they change the mind of the people. They prove that some problems which we thought unmanageable are in fact manageable, and they bring new ideas and also cost reduction. For instance, SpaceX with its idea to have reusable first stage. I don't know if they will succeed, but it's really a new idea, and if they succeed, it's really a breakthrough.
Okay. Are there any other questions?
Yes. I would like to know what do you think about Denis Tito, who wants to send a man and a woman to Mars before 2018? Yeah.
In about 5 years from now.
Exactly. Is it realistic?
Okay.
And why did he do this announcement?
The Mars Society supports totally this initiative. Why? Because, as I said, it's a way to kick the ass of the institution and show that what was thought to be feasible in 30 years can be feasible in a very simple way, I agree, in 5 years. But there is 3 main problems to accomplish this mission. The first one is to find funding. The fortune of Denis Tito is not so big. It's about $200 million. It's not billions of dollars. But he is he is an advisor in the technical field and innovation, and he is in a relationship with a lot of clients, which represent several trillions of dollars of turnover. So he must have a very good contact to find his money. The second point is the problem of reliability of the environmental control system for the spacecraft. He must be sure that the system will be sufficiently reliable for the 500 days of the mission. And we know how to build this kind of system, but to prove its safety on such a duration, it is very difficult. And the third problem is the problem of Earth re-entry. Because of the choice of its trajectory, he will encounter a velocity in atmospheric re-entry which we have never experienced, much more than from returning from the moon. And here also, I cannot envision that the mission be launched before accomplishment of testing of this kind of re-entry. But really, I'm very happy to see that. It's very interesting. Last word for those who read French. We have the French chapter of the Mars Society has just issued 3 days ago a book about the challenge of the mission.
Okay, thank you, Richard. So we have another guest.
Last?
The last one? Oh no, we have another one after that. So he wants to sell us tickets. You will see what kind of tickets.
We have a special bargain for these tickets now up to the 1st of June. The Virgin Galactic tickets will be at $250,000, unfortunately, for the one who have not the time to make enough money before starting. So, thanks to welcome me. I'm Jean-Luc Vibo. I'm the French representative of the first world astronautic company, Virgin Galactic. I wanted to say you a word about Virgin Galactic, which is the first private company dedicated to suborbital flights, for inhabited flight, of course, but also for small launchers. And I would like to say first an introduction about this project, Virgin Galactic, because the way Mr. Sir Branson grabbed all this money to make this big project is quite amazing. He started this project in 2005 with the Ansari Prize you heard about, and the Ansari Prize was sponsored at the beginning by Paul Allen from Microsoft. And then when Mr. Burt Rutan, the engineer of the full project, got this $10 million prize. He shared it with Mr. Branson. Paul Allen stopped the project, and Branson decided to create this company, Virgin Galactic, and say to everyone that he was going to go to space by the year 2009. In fact, we are now on 2013, and the first flight has occurred with a 16 seconds powered flight only the 29th of April. But in between 2005 and 2009, he said to everyone that we would go to space and go to 110 kilometers of altitude and spend 5 minutes in zero-G conditions. So people check their tickets, but maybe you don't know, but if you take a ticket with the Virgin Galactic, if you make a reservation on the flight, you can get your money back at any time. So in fact, he couldn't get the money from the tickets to build the project. Yet, he saw some investors, and by the year 2009, he sold 35% of his company, Virgin Galactic, for $350 million. So he evaluated his whole company by 2009, 4 years after starting, $1 billion, without any flights from the shuttle. So that is just this remark I wanted to tell you, because it's very interesting to notice how we can sell in this world the part of dream. And selling this part of dream of the project, he added value to the Virgin Galactic name. In marketing, it's adding value to the brand. And in 4 years, without selling everything, the valuation was $1 billion. And the remarkable thing is that with this money, he started the whole project, really. And now we have the first flight in 2013. So it may give some ideas to someone who has some difficulties to find money, if you have enough charisma, and we have some in Europe, we could maybe have some kind of project. And it's a true experience of how the private sector can have a real targets and very ambitious targets in space. So, Un Ticket pour l'Espace is just my website, and I wanted to show you the marketing effect of what I just tell you about. This is one video, for example. Oh, this is another video. I don't know if you would appreciate. This is a no, for another time. It's an eclipse I did with a eclipse trip I organized in Polynesia in 2010. Another trip also in Concorde in 1999. I'm sorry. This is another subject. But we organized with this company, Un ticket pour l'espace.fr. I'm sorry, I can't go through on my video. We organize different trips, and we send people in space also, of course. We do zero-G flight, and we also go in Mongolia, Bolivia, and so on. Kenya for the next eclipse. And now a little video on, yes, I'm here, on space. I hope I'm on the right one. Yes. This is the flight. It's a very short flight, short sequence, but it's quite interesting. Can you see it? All right.
Can you put full screen?
Full screen. Help me, please. All right, some aspects about this powered flight, this first powered flight. Now you may be interested in this project, so I give you some information about the plane. White Knight is the big 4 engines that carries the shuttle. White Knight is powered by 4 engines of 7 tons each, and there is something very interesting about this plane you can see there. It has 2 fuselage, you say 2 fuselage? And the fuselage has exactly the same shape as the shuttle. Why? Because Mr. Rutten was quite clever, and he said maybe people that would go in this shuttle will be afraid or wouldn't be in a very nice situation. How can we train them to be at ease in the volume of the shuttle? And the answer is, we will do exactly the same volume and the same interior, the same seat, the same windows in the shuttle than in the White Knight plane, in order that when the clients would come on the premises and they would train on the spaceport, they will have a flight, a zero-G flight, in the White Knight plane. And this White Knight plane is made with to resist to high Gs. It's my memory, I think 4.5 positive and 6 point negative. And so the candidates for space would first train themselves in this White Knight plane. And in the end of their zero-G flight, they will decide whether yes or no they would start in the shuttle. Because, of course, we have no experience of these flights for the usual people like everyone here. So they have to take some precaution, of course. If I detail the flights, first you start from Las Cruces, near El Paso in New Mexico, a spaceport designed by Mr. Forster, a very nice place, but lost in the desert. And then you have 3 days of training, test medical training, of course, and also this zero-G flight I was telling about. And then if you decide to go in the space shuttle, you share your flight with 6 other passengers, 2 pilots, and you climb with the White Knight plane to 15 kilometers, then the plane releases the shuttle, and then the speed of the shuttle starts from 800 kilometers up to 3,500 kilometers during about 70 seconds, 75 seconds. The acceleration is estimated to 3.5 G. After the altitude of 65 kilometers, the engine stopped, and as you know, they had some problem and delay about propulsion up to now. The first start I was telling about was 16 seconds, but they have, if they want to go to 110 kilometers, they have to go on at least 75 seconds at full speed. with this hybrid engine. Maybe, I don't know how to translate, it's made out of, the petrol is polybutadiene and nitroxus. Sorry, I don't know how to translate that. Briefly, when we arrive at 65 kilometers, the engine goes on, the shuttle goes on up to 100 kilometers. And then the forces are balanced, and then we are in zero-G conditions, estimated to 3 to 4 minutes. Then there is a feathering system, meaning that the wings will fold when the shuttle is nearly at zero speed, I would say. Then there is gravity effect, and the engine is coming back, the shuttle is coming back to the ground. The overall travel is about 2 hours and 30 minutes. And there is 50 minutes with a white knight plane, and then there is 90 seconds of climbing for about 4 or 5 minutes in the end of the flight, and then going back to Earth, gliding on the same place, of course. That's for this flight, and it costs from the 1st of June $250,000.
Okay, thank you. Well, we can take a few questions.
I have a question. How exactly does this relate to the West Side Story?
Sorry, this is a private.
Because
joke.
I danced? That's what you mean?
Good answer. Thank you.
Sorry.
How disappointed would the customers be if the community decided suddenly to set the border to space at 120 kilometers?
I didn't get that.
Sorry.
Well, the border to space is just 100 kilometers by definition, and I believe many people would also buy that ticket partly because they can say, I have been to space. What now if the community decided, okay, we're gonna set the border to space not at 100, but we're gonna change it, we're gonna set it to 120 or 130 kilometers, so then those people wouldn't have been in space.
Yeah, but SpaceX, I think, is proposing some kind of travel. There is X-Core also, climbing people first to 60 kilometers. I think Thomas is calling me. I think Branson used this frontier of 100 kilometers for a marketing issue, but you know, it's true that there are wow. There are several clients who took their tickets to make some. They made some marketing with this, you know. In France, we have 13 clients who bought their tickets out of 600 from 48 nationalities. And I think that among these 600 clients, there are many people who try to make communication on their own through their tickets. In fact, I don't think they are going to space. They just want to tell about, they want to take advantage of their tickets, that's all. So there is no real frontier.
Thank you.
No.
Thank you. So you can see the astronauts really like SpaceUp. They are harassing us. So thank you, Jean-Luc.
Right. Sorry for the dance.
Okay, so now we will talk with the astronaut Thomas Pesquet, if everything is all right. Okay.
Okay. So, as you can see, we have a special guest. To conclude the SpaceUp, there's a 7 hours difference, so we are really glad that it, here with us virtually because he's in Houston, but still he's here. And so thank you, Thomas, for being with us. And I'll just let you, talk.
Non, c'est bon. Vous êtes toujours là, Brigitte?
Oui, moi je suis là, tout le monde est là aussi.
Ok.
Tout le monde est là aussi.
Moi, je vous entends. D'accord. All right. So, hello everyone. I hope the reception is good. So I remember this room. That was the first room I ever stepped into as an astronaut. I stepped into this room. I was not an astronaut, and I stepped out with my 5 colleagues. That was right the day of the selection. So I hope all is fine. It's Sunday morning here in Houston. It's something like 10 to 8. So I just got up. I had a hard time going through the gates because it's Sunday and I'm a foreign national, so I'm hardly allowed on the premises. I've been following what you guys have been doing for the past 2 days, and it's been really awesome. That kind of initiative, I'm sure you discussed a lot what Chris Hadfield has done. That's really what we need to raise awareness about space and to extend our outreach efforts. So what I'll try to tell you a few words about what it's like to be an astronaut, a few words about the selection, a few words about the present, and then hopefully we can interact a little bit, because the point is not for me to talk for 20-25 minutes. It's also for you to ask your questions, and that's why I'm here today with you. So as Brigitte introduced me, I'm one of the new ESA astronauts. I was recruited in 2009 together with my 5 classmates. We've been dubbed since then the Shenanigans. There's a very long story behind that name, so unfortunately there's no time to tell that story today. But if one day we meet and we have some time and we can share a beer or whatever, I'll tell you the story of that name. So since then, there's been first basic training, which is the first step of the astronaut education. That was 1.5 years, 2009, 2010. And after that, we all got qualified. We got our nice astronaut's degree. And now we're qualified for a flight to the ISS. So basically, life as an astronaut, it starts with the selection, then you get basic training, and then when you're assigned, all right, we've been cut. Oui. Ouais, mais j'ai un... D'accord. All right, so sorry. We have a communication problem between the US and Paris. So I was just going through the steps of life as an astronaut. So basic training, we all got qualified, and then some of us got assigned to a mission and started their mission training right away. That was Luca's case. He finished basic training 2010, started mission training end of 2010. And for those of us who weren't assigned to a mission right away, we started the pre-assignment training. And pre-assignment training is basically
maintaining your proficiency, and getting some new qualifications for getting high-level tasks when you're on board ISS, which are mainly science, robotics, and EVA. And that's what I'm doing right here at Johnson Space Center, together with my colleague and good friend Andreas Mogensen. We're training in the NBL, Neutral Buoyancy Laboratory, and we're being qualified on the American EVA suit, the EMU, after having been qualified on the Russian suit. So that was in a nutshell what we do as an astronaut. When we're not training, we try to contribute to ESA, to the space community in as many different ways as we can. So for example, as Eurocom of the we're communication between the astronauts and the control center in Munich and the Columbus Control Center. I've been in charge of the flight training of the young astronauts that were not pilots, because I was a flight instructor before. So I was in charge of this. Andreas, he was, for example, working in the Lunar Lander project with ESTEC, because he's an expert on space navigation. So that's basically what we're trying to do. And of course, we're also doing a lot of outreach and education efforts. So we're all active on Twitter, as you guys probably know. Sometimes not as active as you would like us to be, but it's we're trying to dedicate as much time as we can to social media, because we're really convinced as a group, and I guess also at ESA, that it's a new way of communication, and that's very, very efficient, as has been proven by Chris Hadfield. For the time being, we do mostly our social media effort in our free time. I mean, there's no organized way for us to do it, so it's really snapping a picture, finding a caption, and then trying to capture the moment. I think that's really the main point with new social media. All right, so you've seen, I guess you've had a chance to chat with Luca, or you've seen a video about Luca yesterday, and you started with Jean-François Clairvoy, so that's also a nice transition, because Jean-François, he had these shuttle missions in the 90s. Luca is now on the verge of launching to the ISS for his 6-month mission on Tuesday. So that's kind of the past, the present, and hopefully you also mentioned the future of human spaceflight. Even though sometimes the future is not straightforward, there's no straight line. There are many different opinions on what we should do in the future, but all the space agencies are trying to coordinate the effort and to have a common approach to exploration. Hopefully, this exploration effort will lead us one day to Mars. That's what I wish I could do in the future. If there's really one thing I wish I could do as an astronaut, it would be to one day step on Mars. Today, Mars is 20 years away from us. Not really in terms of technology, but in terms of will. So we'll see what comes up in the future. We're training for that. We're preparing for that. But for the time being, we have our ISS missions. So I don't know. I don't want to talk too much. I want to give you the opportunity to ask questions, because really that's what it's all about. So Brigitte, you can moderate. I don't know how you want this to work. It's very open. I'm pretty laid back, so it's nice up to you guys if you have questions.
Okay. Thank you, Thomas. Anyone has questions?
Can I? Okay. Hi, Thomas. It's Starling Alex on Twitter, and I would like to congratulate you, because we all heard that although you have not been assigned a mission, it is now certain that you will also fly to the ISS. How relieved are you, or will you only be celebrating when you actually assign a mission?
So I hear the beginning, but not the very last word. You say we're all assigned to a mission.
No.
And what was the actual question in itself?
Well, I said, I know you have not been really assigned the mission, but it is now clear that you're going to the ISS. So how happy are you? Are you relieved already, or can you not believe it until you are actually assigned to a mission?
You know, it's a very good question. Because in the space industry, you know, we're always prepared. We always make plans for the future. And then it never turns out to be exactly like we planned. So it's good to be prepared, but it's also good to be able to improvise a little bit in that business as an astronaut. In what we do in your everyday life, but also as a career plan. So yeah, I mean, we still have missions coming up, as you said. So we have more missions than we have astronauts, which mathematically gives a mission to everyone, so everyone should be happy, but you never know what can happen. So as you said, and I was very right, I'll believe that I'm assigned to a mission when I see it happening with my eyes, and I'll believe that I go to space the day I step on a rocket and the day I launch. Because until this moment, so much can happen, so much can go wrong, that if you take anything for granted, then you're not going to be in a position to really achieve your dreams. So I keep this in the back of my head somehow, because obviously that's what I'm here for, but I concentrate on my day-to-day activities, and that's really true. I mean, it's not just an expression. And I'm firmly convinced that that's what you should do as an astronaut. You don't think too much about the future, you think about the present, and everything will be fine.
Okay, thank you. Please take a microphone.
Yes, hello. I'm Moritz I'm an aerospace engineering student from Delft, the Netherlands. Thank you for taking the time to answer questions. I'm actually very curious what you think about that so many astronauts have a military background. And do you think that's a good thing or a bad thing? And what's your opinion on that?
All right, it's also a good question. It used to be. But if you look at the proportion, if you look at the proportion, it used to be 100% of the people having a military background, and now we're down to, I guess, less than 50%, of roughly 50%. So the astronaut corps has opened up to all kinds of people over the years, and it's still opening up as we speak. I mean, I'm the first airline pilot, so that was a population we never had before. So that's good. I think that's good. I think that's a trend that should continue, because now we're doing a lot of science on board the ISS, and we're doing so many different activities. The military background gives those guys an approach to exploration, to expedition missions. That is really good. When I went to caves with Tim Peake, I was surprised to see how prepared he was for those difficult environments, how well he was able to deal with all the logistics, how acute his leadership was in those environments, because that comes from the military background. So for expedition types of mission, we still need those profiles, and I guess we'll always have people with a military background. On the other hand, if we really want to be the ambassadors of humankind into space, which is what sometimes people say, then we have to represent everyone, which means not only military people, but also, I would say, not only science people. I hope someday we'll send some other types of personalities in space, people with a more artistic side, writers or journalists or musicians or artists. I mean, we saw with Chris Hadfield what playing music in space can do. So can you imagine if we wouldn't send people who play music as a career? So I'm also very much in favor of this. Some people in the astronaut corps, they'd like to keep it very military, very scientific. But I hope someday, maybe in the next astronaut selection or the one after, we'll also focus on some other qualities.
Thank you, Thomas. We have time for one last question. Please take a microphone.
Hi, when you will be going up, have you thought about your very scarce personal luggage, and are you bringing any cool items?
Oh, so I didn't really get the question. Was it about what I thought I was going to bring to space?
Are you bringing any cool items to space?
In your personal luggage, yes.
In your personal luggage?
In my personal luggage, well, to be honest, I didn't think about that yet because, like the first question we had, I'm not thinking too much about the day I'll fly to space. I mean, it's a little bit bizarre because I'm here as an astronaut and I'm telling you guys, no, I'm not thinking about the day I'll be going to space. But that's really the way it is. I guess the closer you get to the mission, then the more time and the more effort you dedicate to those things. But if you're still a little bit far away to your mission, then you dedicate your time and your effort and you focus on the training. So, so no, I don't know. I think I'll take items for my family to give them something from space. I don't really know why, but I don't really know what, sorry, but probably my brother's watch. He has a nice Speedmaster that was the original moon watch, and he had it the day, the year he was born. So that's a very nice watch. I'll bring it to space, and I'll bring it back to him. I'll try to do the same for my parents. I don't know what I'll bring for me. I guess I don't have to bring anything for me. I'll bring things for the people, really, because I will have gone to space myself. So I don't have to have someone on me reminding that I've been to space. But I guess I'll bring as many presents as I can. I'll bring them up, I'll bring them down, and I'll give them to the people. So if you have something you want me to bring. Now is the time. Send me an email, take a picture, and I'll make a selection of the best items and I'll bring them. Yeah, why not? This one is cute. All right, this one goes.
You just made a lot of people happy. Thank you, Thomas. Okay, we are now going to show a video by a woman, a young French woman who works at GPL with a rover that we quite know well. And thank you, Thomas, for taking the time to be with us. It was a great pleasure.
Thank you, guys. Yeah, thanks to you guys. Sorry about the connection problems. I hope next time I'll be there with you in person and we can share a little bit more time. That would be really, really good. That would be my pleasure.
That would be awesome. Thank you.
Thank you.
Hi, my name is Gabrielle, and I'm a Mars Exploration Rover team member. We talk a lot about curiosity these days, but we forget that it's been more than 9 years. Opportunity is driving on Mars, so let's talk about it a little bit more. In 2004, Spirit and Opportunity between rovers landed on Mars. Unfortunately, we lost Spirit in 2010. But Opportunity is still driving, and it's doing actually pretty well. This mission, the Mars Exploration Rover mission, also known as MER, was actually a key mission to the Mars exploration program because it was the first time that we could establish from the surface that there was at some point liquid water on Mars. We knew from orbit that there was water ice at the poles and water vapor in the atmosphere, and we could see channels from orbit, but it was really the first time that we could find evidence of liquid water from the surface. How is that possible? Well, let's talk about the capability of rovers first. First of all, a rover is not a lander, so it can go from one point to another, and thus it can explore a wider area than a lander can. And then a rover can carry payloads. So the first payload, very useful, is just a simple camera that can take pictures of the environment. So with the pictures you can look at features, you can look at how the rocks look like, you can look at basically what kind of environment you had at some point in this location. You also have on the rover the arm, and the arm carries the experiments. So on Opportunity you only have 4 instruments that can give the mineralogy and the elemental composition of your target. It can take close-up images of the target, and that's how they could find evidence of liquid water. It's by taking pictures and analyzing the elemental composition and the mineralogy. And there are some evidence that some minerals just form under wet conditions, and there is no way you can form them if Mars was dry. For example, Opportunity found what we call the blueberries, and the blueberries are just hematite concretion that formed in acidic water. So a rover, by driving, by going at places that we want to explore, by giving the composition, the mineralogy, by giving us the evidence of how the rock forms, is kind of replacing the human exploration. If we send astronauts to Mars, we would do the same job that we do with the rover. So what exactly are the differences? Well, first of all, the rover is not very fast. Like, it goes only 35 meters per hour. And also, you cannot drive for the entire day. You need to drive only for a couple of hours or so. So it's very limited. And also, there's a communication problem. So when we send information to the rover executes the plan and does what the Earth tells it to do. So for instance, it does an experiment with the arm and then drive. Once it does that, it stores the information in its computer and then sends it to the satellites in orbit around Mars. And then, after all of this, the information on board the satellites is sent to Earth once per day. And the information sent on Earth is a limited amount of data. So we don't get all of it, we just get part of it. And that's why when we plan the rover day, first we do not know what happened the day before, we know only what happened 2 days before. So if we drive, we need to stop and wait for the drive data to come down. And then sometimes we don't even have the drive data coming down. We just have one image and we cannot do anything. So all of this kind of slow down the exploration of the planet, because we cannot drive as much as we want and exactly where we want. It depends on the data we get, and it depends on the communication. And indeed, if you look at the Apollo astronaut on the moon, so far they had the record for the longest driving distance by a rover on a planetary surface. And it took us more than 9 years to break this record, and we finally broke it last week by driving more than 36 kilometers in 9.5 years. So the rover is very capable. It can give you a lot of information about the environment, about how rocks form, but it's very slow. And we need to be patient if we want to get to some target and get some analysis.
Okay, we can applause.
Okay, this was Gabrielle Coutreau, and you can find her on Twitter. She's Galia Marsonaut, and you can follow her on Twitter, and she has really a cool job and lots of interesting things to say. And now to you.
Okay. So Isa has created and printed 6 posters like this for the SpaceUp. So 6 of you will leave the SpaceUp with one of the poster. To find who will do that, we will draw among the people who presented something. So Brigitte or Damien, I don't know. Brigitte will draw the presentations. So it's everyone, T-5 included. So, who did Space Interactive Exhibit? Interactive exhibit. So next one. Gaia, from design to launch. Isabelle? So, I'm sorry about the name. Yeah, it's just a name, Gumiani. Sorry. How do you pronounce your name, your first name?
Przemysław.
Przemysław.
Okay.
Oh God, I have to carry it on plane.
So, Bart Henkeler for Mars One, realistic. Next is space volcanoes.
Last one.
And the last one, Piotr Lefkowitz.
Yeah.
No, don't worry. Okay, I have some very sad news now, and because it is the end of this amazing SpaceUp conference. Yeah, sad. So we have seen a lot of very interesting and exciting talks. We have met some great friends, and yeah, I hope you learned a lot about space and you enjoy a lot this conference. And for all of this, I would like to thank our sponsor, Isaac, Ness, is Space, and CVA, and all the others. And I also would like to give a special thanks, or should I say a special thanks, to Isa for letting us use these rooms. Thanks. Yes, thanks, can help us. I would like to thank Nicola and Roberto, who helped us a lot organizing this conference. I would like also to thank the technical team, Mado. I think we can applaud for them also. And Francesco. And most of all, I would like to thank all of you for making this not actually an unsuccessful conference, but a successful unconference. So we need to continue like this, go forth, invent, discover, and let's space up. Just to finish, maybe you know where is going to be the next SpaceUp. Maybe someone can tell us something about this? You have the last word. Just a final word. Yeah, so Delft seems to be interested. Some others say Toulouse as well. We saw the or London, maybe? Okay. So one final word about security. So the best way is when you leave ESA is to leave and try to find the next subway by going on the right side of the street, not on the left side, because then you go right into the demonstrators. That's up to you. And there's also another station that is that has issues. It's Opera, so try to avoid it as well. Opera.
But before you leave, I mean, a lot of people have been thanked, but of course the most important people this weekend have not been thanked, and I guess we can't really thank them enough. But on behalf, I guess, of SpaceUp Europe, I mean, a few of us took SpaceUp to Europe a while ago, but also on behalf of all of us in the SpaceUp movement, on behalf of Chris Radcliffe and the SpaceUp Foundation, of which I'm one of the members, I would really, really like to thank you for an awesome job done. Thank you very much, guys.
Yes, thank you so much. And I think Remco, Jo and I, we sort of know how much work it is to set up something like this, although this was, I believe, just twice as much work as the one that we did. So really did an awesome job. Everything was so well organized. Thanks again to ESA. It was a great honor for us to be here in that very room. And it's only a very small thing that we have here, and actually it's just 3, but there's two pieces in each, so I think you will have to do the lottery, as I see you're actually 7. But most of us, I think, signed these little Lego balls, the Star Wars, and we would like to give this as a little thank you and a little souvenir, and to express our gratitude for this event.
And I just want to add that we are 3 here now, but there are 3 other members of SpaceUp Europe in the team. That's Angie, Aiko, and Marco, who are not here, but are here with us in spirit.
Simply to tell all of you that we at ESA, we have been extremely pleased and honored to have this team of passionate about space, and I promise wherever you go next year, ESA will be supporting you. If you go to the Netherlands, we from ESTEC will support you strongly. If you go to the UK from Harwell, the same. That means we have many chances to help you wherever you go. In any case, you have all our support. Thanks a lot. Wow.
Okay, now you're free to go to other SpaceUps.
Congratulations. Merci en tout cas.